Okay, today I'd like to finish up the Excel workbook by completing the fourth and final sheet in this demo file here. So we're going to switch over to the VLOOKUP starter file, the last sheet here, and I'm going to make sure that we see everything in here. The first thing I'm going to do in this sheet is to add an extra line in the very first row. So I'm going to come up to row 1 and highlight row 1 by clicking on the 1 over on the left-hand side, and then insert a row so that we can put our name, class, and everything in here that we need, as well as enter a problem statement at the top of the sheet. So I'm going to type in my name, and I'm going to put the class in column D instead of column C today, just to kind of offset it, putting the date here in column G. And again, I'm going to click on that 1 and do a Control B to make it everything in that row bold. And then I'm going to do my problem statement. So today we're putting all these skills together that we've learned to complete the real world manufacturing problem example. And again, I'm going to click on row 2, and I'm going to make this italic. So I'm going to come up to the top and make it italic so that it kind of stands out. It's the header of our sheet. So you're going to notice that we've got 4 different tables within this sheet. So this first table has purple headers with bold white font. Then it's got a corresponding just blank cells here next to it in column B. Table 2 covers rows D4 through J24. And then our third table over here has materials and specific gravities, and that is from L4 to M13. And then lastly, we have a little kind of corresponding table down here off of manufacturing site that corresponds to table 2 with a bunch of cells here that we need to fill in. So I'm going to zoom in so that as I get going on this, you can kind of see exactly what I'm doing. So I'm going to have my screen only fit table 1 and table 2 here for the most part. So the first thing we need to do is we actually notice that column F is not completed in table 2. So with column F, it's a part number, but we notice that column D contains a part code 1 and column E contains a part code 2. And so what it looks like we need to do is actually complete the part code or part number, combining part code 1 and part code 2. And so you can do this in 2 different fashions. This is called concatenation. And that concatenation, I can either write it as a formula or I can use our concatenate function to put the 2 together. So I'm actually going to write this as a formula. So in here, I'm going to start with my equal sign. I'm going to use my cell references. So I'm going to click on cell D5. And then to concatenate in a formula aspect, I'm going to use an ampersand. And then a set of double quotes because I want to be able to space these out. And so I am going to put a dash in between my part code 1 and part code 2, or you could put a dot or just a single space. So you can kind of have it show up however you would like. And then once you're done filling in what goes between your 2 parts, you add another ampersand. So that's shift 7. And then I'm going to do my cell reference for E5 to combine my 2 parts. So when I hit enter, I get DSS space 101. Or if I want to come back into my formula and I want to add that dash instead, I can add my dash, or I can add a space on either side of my dash just by editing my formula between what happens essentially between the double quotation marks. Then I can change what occurs between my 2 cell references. So Once I have my part number, I'm going to center my part number in my table because everything else is centered. We also notice that our font size is way different than everything else. So we're going to make our font size the same as all of the other text in here. And then I'm just going to double click at the bottom corner to make sure that this completes my column F within table 2. Now all of my part numbers exist and are currently highlighted. And what we notice is that these part numbers correspond to kind of what we want in table 1 is the fact that in B4 we want to display a part number. And like I was doing in the last spreadsheet, we use data validation to create a drop down so a user could select from those. So that's exactly what I'm going to do is I'm going to click in B4, I'm going to go over to the data tab, and then I'm going to go to data validation, create my list, source from column F, so F5 through F24, click OK, and so now I have a drop-down list. So I'm just going to select EAS-104 as my part number so that I at least have something selected here when I go to fill in the rest of table 1. So based on this, we have a part number. Now we want to find the corresponding length, radius, material, and manufacturing site from B5, B6, B8, and B11, because all of those things come out of our table 2 here. So we've got our length in column G, our radius in column H, our material in column I, and our manufacturing site in column J. So easiest way to do this, instead of having to write all of those nested ifs, because we've got a lot more options in the spreadsheet, is to do our VLOOKUP. So we're going to type equals VLOOKUP, and we are going to look up the value from B4. We're going to look it up in our table, but remember that our whatever value we're looking up B4 needs to occur in the first column of our table. And so I'm going to make my table as F5 through J24. And the reason I'm doing the full table instead of just doing from part number to length F4 to G24 is because I'm actually going to copy this because we've got 4 different lookups for each of the different columns within this full table. So I'm going to do a lookup for column 2, a lookup for column 3, a lookup for column 4, and a lookup for column 5 to pull all the corresponding information out of this table based on whatever we select out of column 1, which is column F in our table. And so here I'm pulling my length out of column 2 of our 5-column table, and then I want an exact match, so a false, to my B4 that I'm looking up. So if I hit enter, I end up getting a length of 6. So if I go down to my table and look up EAS-04, I have a length of 6, a radius of 4, material of copper, and a manufacturing site of Ashland, Ohio. Well, what I notice is that my length here is reported in inches, and what I really want is my length in centimeters. But I'm going to come back and do that conversion in just a moment. First, I'd like to make sure that when I do my VLOOKUP, if I wanted to copy this and paste it, I can do that, but I get an error when I paste it. And I'm getting an error because I'm now referencing a 6, which does not occur in the first column. And we notice that when we click back in our equation here, we notice that our table has shifted down. So I'm going to escape out of this. If you are ever in a formula and get stuck in it, you can hit the escape key to get out of it. And go back up into my original VLOOKUP statement. And in my VLOOKUP, I'm going to start using cell addresses. So I'm going to do my absolute cell references for B4, F5, and J24 so that nothing shifts when I copy and paste this. So now when I hit enter, come back, click up in my cell, control copy, and then control V to paste, I now get a second 6 here. I'm going to paste this again. So copy and paste it in my material and my manufacturing site, because now I'm copying the same exact formula for all of these. Now the only thing I've got to come back and update here is what column in my VLOOKUP my data comes out of. So my radius comes, we have right now, we're pulling out of column 2, which is length. We need to move over to column 3 for my radius. For my material, what column should my data come out of? Well, not 2, because that's my length, but it ends up being column 4. So now copper appears because EAS is selected. So we want copper, and then we want Ashland, Ohio to appear. So we need to come up and update our VLOOKUP statement, have a 5 for our column to pull our manufacturing site. So now we've got all of these in here. We notice that they're not centered. So I'm going to come back up to my Home tab. I'm going to center my values, and then I'm going to come back up and do my conversion from from inches into centimeters. And so we remember that 1 inch is equal to 2.54 centimeters. So when we turn that conversion So we are reporting out inches. So when we convert inches, we really just need to take our VLOOKUP statement. And at the end of our VLOOKUP statement, we need to multiply by 2.54 in order to get from inches into centimeters. So we get a length of 15.24 centimeters in the end. So we're going to do the same thing with our VLOOKUP here, because again, we have a radius reported out in inches in table 2, yet we want it in centimeters. So now I've got 2 of my values calculated properly in centimeters. And now we want a volume. So if we have a length and a radius, what assumption are we making about the shape of what we think we're manufacturing? So we have a length and we have a radius. So we must have a cylinder for our manufacturing parts. And so the volume of a cylinder, based on our conversion equation sheet, is pi multiplied by our r squared. So we're going to do our cell reference for our radius. So our radius comes out of B6. So B6, we're going to square that. Then we're going to multiply that by our length, which is in B5, in order to get our volume of our cylinder. So our volume of our cylinder ends up being 4,942.22068 centimeters cubed, although that's way too many decimal places. So we're going to start to reduce our decimal places. And at this point, really probably either no decimal places or a single decimal place is probably the most proper notation for this. And then from this, we have our material of copper, which we did our VLOOKUP for. But now we need to find the specific gravity. And then once we have our specific gravity, we need to have, or to determine our part mass in kilograms. And so if we have centimeters cubed, what other assumption are we going to make when it comes to our specific gravity? So remember, so our volume of a cylinder was equal to pi r squared h, and then our specific gravity is equal to the density of our object divided by the density of water. And then that means that one of our other assumptions is that we need our density of water. Probably the easiest density of water here in our conversion is going to be 1 gram per centimeter cubed, or 1,000 kilograms per meters cubed. Because we already have a volume in centimeters cubed, it means we can go grams. And then in our conversions, I'm going to shift these up here, we know that 1 gram is equal to, or 1,000 grams is equal to 1 kilogram. Or we may say our centimeters cubed to meters cubed conversion here, where we have 100 centimeters in 1 meter, and then we could cube that in order to do that conversion if we wanted to. You can do it either way. I just find it's easiest to go from density of water of 1 and then our 1,000 grams into kilograms. So first we need to pull out our specific gravity, and our specific gravity is found over here in table 3. And I'm just going to label this here. So our table 3, we have all of these different materials that these manufacturing parts could be made out of, and then their corresponding specific gravities. And so we need to do a VLOOKUP for our material, which is in B8. Then we're going to look that up over here in this little table in L5 through M13. We're going to look in the second column because it only has 2 columns. And again, we want an exact match, so we type false in order to pull the specific gravity of copper. And you can see that if we were to update our parts, all of these values are going to update accordingly based on what information we select out of our drop-down. So now the only thing we need to calculate is our part mass. And so for our part mass, we know our last equation is that our density of our object is equal to our mass divided by our volume. And so we know that we've got to rearrange this equation. So our mass is going to be equal to our density of our object. Well, we've got to rearrange this for our density of our object. So our density of our object is equal to our specific gravity times the density of water. So our specific gravity is found in cell B9 times, and then our density of water, which is going to be our 1 gram per centimeter cubed, or you could type 1,000 kilograms per meters cubed here. And so this is our density of water. And then we're going to multiply that by our volume. Ohio. Had an extra space at the beginning of my equals sign, so it wouldn't recognize my cell references. So times my B7. So that gets me into, since B9, my specific gravity is unitless. Now we get this into grams per centimeter cubed, multiplied by centimeters cubed gets us something in grams. And so now we need to get from grams to kilograms. And so we need to then take this whole thing and divide it by 1,000 to get it into kilograms. Again, we end up with way too many decimal places, so let's take this down to 2 decimal places. So we have 44.28 kilograms for our part, if it is produced out of copper. So if we change this to say DSS01, we have something that is 12 inches long and 4 inches in radius, so 8 inches in diameter, or 30.48 centimeters by 10.16 radius centimeters. So a volume of almost 10,000 centimeters cubed is going to weigh 13.64 kilograms if it's produced out of PVC, which has a specific gravity of 1.38. The specific gravity, remember, is unitless, which we can indicate in our sheet here. Okay, so that completes table 1 over here for our user based on what they are doing. So let's come down and let's kind of figure out, so we've got table 2 here, and then we've got all of our different manufacturing sites, and we want to know how many parts are produced at each of our manufacturing sites. So we can create a formula here, and we can actually use a built-in function called count, and we can count all of the functions of a certain thing, or we can use a COUNTIF and designate a condition that has to be met in order for it to count. And so using our COUNTIF, we are going to highlight our little table here with all the different manufacturing sites. So we've got our range of values, and now we need to designate what criteria it's going to count if it matches. And the easiest way to do this is, instead of typing Asheville, Ohio, we're actually just going to click over, because we've got it written in a cell in J27. So we can finish out our statement and hit enter. We can say, okay, there are 10 products that are manufactured at the Ashland, Ohio facility. 1, 2, 3, 4, 5. So all of the DSS dash parts, 2 EAS parts, 1 JBS part, and 2 KAS parts. So 2, 3, 4, 5, and 5 more makes 10, so our count is correct. So when we copy this down, if we go back and look at our equation and click back, well, our J28 updated and moved down, which is great, but our table is actually off by a count. And it doesn't necessarily impact this count, but if our second one on the list was Ashland, Ohio, it would impact the count. So you want to make sure that you use cell addressing. So we come back and escape out of our equation, go back to our original equation in K27, and update with absolute cell addressing of our J5 and J24, so that when we copy this down and fill in the rest of the table, it does its count accurately. And the last thing I want to do is I want to add in another little table over here. And so I'm going to add 3 little cells. So I'm going to highlight the cells that I want to make, and I'm going to color code similar to table 3. So this is kind of adding on, appending to table 3 area over here. And so I'm going to add borders. So I'm going to do all borders to match my other tables. And then I'm going to highlight these first 3 cells. And I'm going to come up to the top, and there's this little paint bucket. So I'm going to fill it with a color to match. And I'm actually going to go just a tad darker. You can pick one of the blues to fill in with. And then I'm going to do white font in these cells that is bold. Now I'm going to look up the max specific gravity, the min specific gravity, and then the material with the max specific gravity. So again, I'm going to make all of these match my fonts from previous headers. And so if I want to look up, and I'm going to center my headers so that they look nice in my table. If I want to look up the max specific gravity, we've got built-in functions to do that. So I'm going to start with my formula, type max, and then I'm going to look up the max value out of a range of cells. And so when I just click on one and highlight, it automatically uses this colon here to indicate that we are working with that range of cells or that array of cells. And so I can do the max here of M5 through M13, and it's going to give me a max value of 19.3. So again, I'm going to center my numbers, put them in the same font, and then I can do the same with my min. So my min function is just min. And again, I can specify all of the values that I want to indicate in here. I could have also maybe pulled the minimum length or maximum radius of my parts, so on. But you can do a lot of different things with a bunch of different functions depending on what information you want out of your spreadsheet. Now, if we want to look up the material with the max specific gravity, that's a little more difficult than our VLOOKUP that we've been using. And so here, we've pulled our value of our max specific gravity out of this table here, and then we want to go backwards from column 2 to column 1 to output what the material with the max specific gravity is. And so in order to do this, we need to actually index what location our max specific gravity comes out of, and then tell it where to pull that information from. So we're going to use a function called match. And so we are going to look up, and so this kind of works very similar to our VLOOKUP, a match does. So we are looking up a value. So I already pulled my max specific gravity. So my value is M15. I'm going to look it up in a table or an array of some form. And really, you want to indicate just a single column or a single row of data that you're looking this up in. So your array should be a 1 by something or a something by 1 in order to pull the right information. And so you're looking this up, and then you want an exact match. So we're going to indicate a 0 here as an exact match for what I'm looking up. So we're not telling it what column to pull from, like our VLOOKUP, but this essentially is going to tell us what row, because we used a column of data, what row our maximum value is located in. So we are matching this to figure out what its position is in that array that we designated. So this gives a position using our match function. And then if we want to pull something from that, we are going to index and we need to tell it where to index from. So we are going to index from this whole table, L5 through M13. And then we are telling it we want it out of row. And so remember, our match outputted a number because it told us what row that maximum value came from. And then we are going to tell it what column of our data. So really, we want this out of column 1 now. And that is going to give us gold. And so if we didn't say want the maximum specific gravity, but instead wanted the minimum specific gravity of these values, I can actually nest my min function right inside of my match function. So you can, again, nest multiple functions inside of each other to pull different information. So if I change this to my min specific gravity, I indexed that same table. I matched the minimum specific gravity out of this array in this array with an exact match, and then I'm indexing this row and column 1 out of this data set. And so this gives you a little bit more functionality if you've got to work backwards in tables based on a column in the center of a table. And that will conclude our Excel demo file. So once you've got all of your data in here, go back to where you downloaded your Excel spreadsheet from and upload your completed Excel spreadsheet with all 4 data files in it up to that link for your assignment grade.